Let's continue work. In the previous lesson, we implemented the functionality of our application using callbacks and discussed the disadvantages of this approach. The developers of the Kotlin language thought about making working with callbacks more convenient, allowing the programmer to write code as if it were asynchronous, while in reality, all the work with callbacks would be hidden under the hood. And so they created coroutines. To use coroutines, we need to connect a library. Let's find the appropriate dependency. We need Kotlin coroutines, so let's type it. Kotlin coroutines, and we search for the dependencies in the Maven repository. So we write Kotlin coroutines Maven. We go to the Maven repository, choose the latest stable version without any RC or beta labels. For now it's 190. We select it, open the Gradle Kotlin section, copy this dependency. We don't need runtime only. Now we go to build Gradle, and in the dependency section, we call the function implementation, and in quotes pass the dependency. After that, we synchronize the project by clicking on the elephant icon, and wait a bit while the necessary dependencies are loaded. So the project is synchronized. Now we can work with coroutines. Let's work in a separate package so that you can see both examples in front of you, and the one with callbacks and the one using coroutines. We'll also need the classes display and file test, so we can copy the package callbacks, paste it into the Kotlin folder, and give a name to this package. In it we'll work with coroutines. Let's name it accordingly. If you copy an entire package, all its contents are preserved, including the package name at the top of the file. So now we have the package coroutines, and it has the class display, but its package is still callbacks. This needs to be changed to coroutines. Let's change it. We press the key combination Alt-Enter or Option-Enter on Mac, and choose Change Files Package Name to Coroutines. We do this in the class display, and also in the file test. If you don't change it, you'll get an error saying that two classes with the same name are in the same package. And today we'll work with the class display from the coroutines package. So we talked about how programming with callbacks is not very convenient. Let's get rid of them and return to the first implementation where the methods had normal return values and no callbacks. We delete the callback from here and make the return type book. Inside we simulate loading data for 3 seconds, and then return the loaded book value. We'll work with the method loadAuthor a bit later. Now we change the place where this function is called. Now we have no callbacks. We return the previous implementation. We load the book, store it in a variable, and then work with that variable. So we are back to the very first implementation where the thread was being blocked. We can make sure of it. When clicking the button, now timer stops displaying any values, and only after that the information about the loaded book is displayed. I remind you that here we are writing fully synchronous code. It's executed sequentially, line by line. The coroutine developers wanted asynchronous code to still look synchronous to the programmer, so there are no explicit callbacks here. The functions we will write have regular return types and no callbacks. And to work with coroutines, we need to make a few changes. First, we don't want to block the thread. We need to remove the call of the method thread_sleep. Instead of making the thread sleep for 3 seconds, we would like the function to suspend its execution for 3 seconds and release the thread, so that during this time program could continue working without freezing, with the timer running and all rendering happening without problems. And after 3 seconds, the program should return to the same method loadBook, starting from this line, and returns the loaded book. For this, instead of the blocking function thread_sleep, we call a function from the coroutine library, called delay. And in parentheses, we also specify the number of milliseconds for which to suspend the function. Notice that now we have this kind of arrow, and also we got an error. The suspend function delay should be called only from a coroutine or another suspend function. What is this about? Recall that throughout this course we've never had cases where a function would suspend its execution somewhere in the middle, and then return to the same function, but now starting not from the beginning, but from somewhere in the middle or end. How the Kotlin developers implemented this behavior, we'll look a bit later. What you need to understand now is that the functions we are calling here are not ordinary. Unlike regular functions, they have the ability to suspend. In other words, to pause and then return to this function starting from the next line. To tell the compiler that this function is special, that it can suspend at a certain moment and then resume execution, we need to add the keyword suspend. Now the error here disappears. But if you look at the place where this function is called, we will see the same error. Suspend function load book should be called only from a coroutine or another suspend function. The arrow in the left indicates that we are calling a suspend function. Let's think, why can't we just call it right here, in this way, without any additional code? You're watching a video from our Kotlin programming course. I have left a link to the full version of the course as well as the biggest discount available in the video description and in the pinned comment. Enjoy watching. Here we have regular synchronous code. All lines are executed sequentially. And we assign the result of the method loadBook to the book variable. If this function were blocking, meaning it blocks the thread, then the behavior would be clear. The thread would sleep for a few seconds, we would wait to receive the value, put it into the variable, and the code would continue execution. But now we've made this function suspendable. This means that when calling this method loadBook, the thread will not be blocked, but instead will be freed, and the program will exit the method. And only after the book is loaded, its value will be assigned to the variable, and the function will continue execution. Regular functions can do this. That's why an error appears here. Suspend functions can only be called from other suspend functions or from coroutines. The same exact error occurred when calling the function delay. Delay is also declared as suspend, and that's why it can be only called from other suspend function or a coroutine. In this case, we're inside a lambda expression. Here we opened the curly brace, and here we closed it. This code is executed once the button is clicked. And in this case, we cannot make this lambda expression suspend. That's why the second option fits us. The suspend functions can be called from a coroutine. Now we'll have several concepts at once that we'll apply in practice, and we'll study them in more detail later. At this stage, we just need to learn how to launch coroutines for execution. Remember threads. Inside them, we can launch some work. And on the instance of the class thread, the created thread, we can call various methods. We can call the method join and wait for the thread to finish its work, or we can stop the thread or monitor its state. In the case of working with coroutines, we must also have the ability to do all this, to wait for coroutine to finish, stop the coroutine, or monitor its state. Therefore, all coroutines must be launched inside some scope. Scopes can be created in various ways. For now, let's use an already created scope called global scope. In practice, it's almost never used. In the following lessons, we'll look at coroutine scopes in more detail and learn how to use them properly. But for now, let's focus only on launching coroutines. To launch a coroutine, we need to call the function launch in some scope. In this way, we create a coroutine and launch it for execution, just like we did with threads. And inside the coroutine, we can perform absolutely any actions. We can call regular functions and regular code, as well as suspend. So let's move all this code inside the coroutine. Now pay attention to what will happen. At this point, you can imagine that creating a coroutine is like creating a thread. In reality, the process is quite different, and we'll look at how exactly in the next lessons. But for now, just for understanding how to work with coroutines, imagine this line as creating a thread. The function launch creates a coroutine. It must be called from some scope object. In this case, we called it from global scope. It's highlighted in yellow because this scope is not recommended for use. Why is that so? We'll also discuss in the next lessons. So the coroutine is launched, and then all this code is executed. We can run regular synchronous code, or call suspend functions that only look like synchronous, while actually hiding the work with callbacks. And the following actions will occur. And the button will have its enable value set to false. The text will be set, and then the method loadBook will be called. And then the rest of the code stops executing until the book is loaded. The thread doesn't stop. It's freed until the book is loaded. When the book is loaded, we'll return to this method, starting from this line. The variable book will be assigned the value of the loaded book, and the code will continue to execute. The text will be set in the text field, and the function load author will be called. At this stage, loading the author uses the callback mechanism. Now modify this function yourself, so that it becomes a suspend function, and doesn't use callbacks. I'll give you a few seconds to pause this video and solve this task on your own. When you're done, run the program and make sure it works. And please note that there is no need to create another coroutine. We'll call all suspend functions right here, inside the same coroutine. So pause the video and try to solve it yourself. Good luck! So I hope you did it. We changed the function load author it will be a suspend function. We don't create any threads. Instead of thread sleep, we call delay, remove the callback from here, and make a proper return type for the function. I just remind, the creators of Coroutines wanted the code to look like it's synchronous, which is why no callbacks are used here. Here we call the function load author and store it in the corresponding variable. We remove the lambda expressions, and once the author is loaded, its value is also set in the text field, and the button becomes active. Let's run the program now to check how it works. The timer runs successfully. We click the load book button. No blocking happens. All the text is displayed successfully. And after all the data is loaded, the button becomes active. And there is no more blocking in our program. We will take a closer look at what's happening in the program in the next lesson. But for now, let's go over once again what we learned today. Coroutines allow you to perform long-running tasks without blocking the thread. These tasks are created inside the so-called suspend functions. And this is a special type of function that can suspend its execution somewhere in the middle and then resume from that exact point where the function was suspended. At first glance, all this may seem like magic, but in reality the usual callback mechanism is used here, which we looked at in the previous lesson. But these callbacks are hidden from the developer, and everything looks as if we are writing regular synchronous code. Just all the lines are in order, and no callbacks. Due to the nature of suspend functions, they have limitations. They can only be called from other suspend functions, or from a coroutine. To create a coroutine, you need to call the function launch from some scope object, and in curly braces, write the code that should be executed inside the coroutine. There are other ways to create coroutines. We'll look at them in the future. Also, using global scope is not recommended in practice. We used it just to launch a coroutine and see how it works. We'll go into more details later on how to create scopes properly. If everything is clear to you at this point, then move on. See you in the next lesson.